continuation, again with horizontal curves, this is the last type of horizontal alignment, which is your spiral curve. Makinig po na mabuti dito dahil wala po ito sa inyong module. So as much as possible, I'll try to give an example with spiral curves. So wala ito sa inyong module and most of the time, ito yung lumalabas sa inyong board exam. Ano? With spiral curves, these are used to overcome abrupt change in curvature and super elevation that occurs between tangent and circular curves. Though most likely roadways that has an excessive super elevation like mountainous terrain, or specifically example here in Baguio City, which the speed limit on the turns or each curves are then designated based on the super elevation assigned on the road. That the super elevation is then part of consideration in forming or using spiral curve, which is that occurs between tangents and circular curve. So originally, this is a simple curve, but due to some revision based on the super elevation and required average velocity, we will then be considering spiral curves. The spiral curves is used to gradually change the curvature and super elevation of the road. That's called also as the transition curve. Here are the new terms and elements of a reverse curve. So elements of reverse curve, we have the tangent to spiral. So basically, ito yung ating original na simple curve. But by adding an extended curve on both endpoints, we will then be having spiral curve. TS is your tangent of the spiral. SC is your spiral to curve. Spiral to curve. Then CS is your curve to spiral. ST is the spiral to tangent. LT is your long tangent. ST is your short tangent, or is the radius of the simple curve, which is in this figure. TS is the spiral tangent distance. Spiral tangent distance, which is TS to SC. And TC is your circular curve tangent. TC, ano ba yung TC dyan? T sub C is your circular curve tangent, or yung length ng curve sa TS going SC. Then length of the spiral from TS to any point along the spiral. L is the length of the spiral. Baliktad po yung nailagay nila dito sa figure. Yung LS dapat yung nandito sa L. Then yung L yung nandito dapat sa LS. Then PI, point of intersection. I is the angle of intersection. IC is the angle of intersection of the simple curve. Then P, or small p, is the length of the throw of the distance, or the distance from the tangent that the circular curve has been offset. Nandito yan sa next figure natin. Now, for the x offset distance, which is your x offset distance to the right angle distance from tangent to any point of the spiral. XC is the offset distance, right angle distance from the tangent SC. Y is the distance along the tangent to any point of the spiral, either if they are in first quarter, second quarter, or fourth quarter distance of the spiral curve. Then YC is the distance along tangent from TS to point at right angle to SC. Then XS is the external distance of the simple curve. Theta is the spiral angle from tangent to any point on the spiral. Then theta S, is the spiral angle of the tangent at point SC. Dito yan. Then I is the deflection angle TS to any point on the spiral at its proportional to the square of its distance. Then I sub S, deflection angle from TS to SC. Then D is the degree of the spiral curve at any point. DC is the degree of the simple curve. Andito po yung mga yan. Ito yung ating theta S, theta, IS, and I. Okay? Yung I is the deflection angle at offset distance X and Y. IS is the deflection angle at the offset distance of the spiral curve and Y. Okay? At any point yung theta ha, at saka yung I. Yung theta S at saka IS within the span of this spiral curve. So yung hinabi ko kanina, baliktarin nyo po yung L at saka LS. Dapat yung L, length of the spiral at any point within the spiral curve. Then LS is the length of the spiral curve. Then formulas to be considered for spiral curves. Distance along tangent to any point on the spiral, which is your Y. Sabi ko nga, to any point. It could either be the first quarter point, second, third, and fourth. Pag fourth quarter, big sabihin that is the full length of the spiral curve. At any point, Y is simply equal to the length of the spiral curve considered within the total span minus that length raised to the fifth 40 radius of the simple curve squared times the total length of the spiral curve LS squared. At L or equal to LS, Y will also be equal to LC. So if we are now asked to identify the total length of the spiral from TS to SC or the tangent distance, Y sub C is simply equal to the total length of the spiral curve LS minus LS cube over 40 R squared based on this figure. Now, for the offset distance from the tangent to any point on the spiral, again, to any point of the spiral, it could either be the first, second, third quarter of the spiral curve length. So X will now be equal to L cube over 6R LS. L yung concern length ha, then LS yung total length ng spiral curve. Thus, if now we are considering the total offset distance referring to the total spiral curve, offset distance is from SC to the tangent line, which is simply equal now to the total spiral curve length LS squared over 6 times the radius of the simple curve. Length of the throw. Yung length of the throw, yung point of change from simple curve to spiral curve. Ito yon. From this point towards ST, which is simply equal to 1/4 length of the offset distance XC or LS squared over 24R. Okay? Over 24R. Next one, we have the spiral angle from the tangent to any point on the spiral in radian. Note, in radian po ito Kailangan nyo pang i-convert yan sa angle after which. So if you're going to convert that into angle, anong gagawin natin? You'll just have to multiply that with 180 degrees over pi. Okay? Theta, which is the spiral angle. Spiral angle, ayun o, triangle lang yan o. Triangle. theta is simply equal to L squared, or the specified length at any point kasi yan, L squared over 2R LS, then multiply that with 180 over pi to solve the actual angle. But if we're referring to the total spiral angle, considering the total spiral length, theta S is equal to LS over 2R. Then the deflection angle from TS to any point on the spiral. Now, the deflection angle naman, as you can see in this figure, deflection angle is in the triangle of XC, then the long chord, then your tangent line YC, or Y at any point. So if it is at any point, I is 1/3 theta, which we have already computed here, or simply equal to L squared over 6R LS. L again is the length of the spiral at any given point within the span of the spiral curve. Okay, then LS is the total length of the spiral curve. Then if you're going to consider the deflection angle of the said spiral curve, that is IS, nakalimutang ilagay dyan, that should be I sub S 1/3 of theta S equal to L sub S, or the total length of the spiral curve, over 6 times the radius of the simple curve. Then this angle is proportional to the square of its distance. So if it is proportional, I over IS should then equal to L squared over LS squared. Then the tangent distance, TS, simply equal now to LS over 2 plus R plus P tangent I over 2. Okay? Tangent I over 2 is the central angle. Then IC, theta S, theta S. Question? And some other formulas again. The angle of intersection of the simple curve, as you can see here. Ito na ngayon yung revised simple curve, which is now equal to the angle of intersection for the spiral curve minus 2 theta S. And the external distance from the point of intersection towards the arch of the simple curve, that is R plus P over cosine I over 2 minus R. And the degree of the spiral curve, using the degree of the curve over the degree of the spiral, equal now to the length at any point all over LS. More or less, yan lang naman po yung ating mga formula. Now, if you're being asked to identify the length of the spiral at the fourth quarter, gagawin nyo lang naman doon ay at the first quarter, it's just basically 1/4 of the total length of the spiral curve, or LS, 1/4 of LS. Second quarter is 1/2 of L sub S. Third quarter is of course 3/4 of L sub S. Then if you're now asked the fourth quarter of the spiral curve, the length of the fourth quarter of the spiral curve, that is basically the total length of the spiral curve. No? Triangle lang lahat yan, no? Napaka-easy. Now, for the meantime, try to answer this given problem on your own. Then I'll be sending the lecture later on answering this problem regarding spiral curve. Spiral curve, try to using spiral curve analysis. The tangent of a simple curve has an azimuth of 240 degrees and 300 degrees respectively. The radius of simple curve is 300 meters without changing the direction of the two tangents, and the point of the tangent C shall remain the same. The simple curve is to be replaced by another curve having 100 meter spirals and offset. An offset distance of 7.882 meters. So sinabi na niya yung length ng ating spiral curve which is your L sub S, 100 meters. Ito ngayon yung revision na gagawin. Then the X sub C or the offset distance of SC towards the tangent line, which is 7.882 meters. In its ends, find the following. The radius of the new circular curve. The length of the throw. Original radius is 300 from simple curve. Then revision, gawin daw natin siyang spiral. Length of the throw, yung ating small letter P. C, the central angle of the circular curve. The external distance of the spiral curve. The deflection angle at the end point of the spiral. And find the offset distance of the first and third quarter point. So kailangan natin kunin yung X sub 1 and X sub 3 offset distance from the spiral. Then again, you'll have to draw your figure. Okay? Try to do this on your own muna bago natin i-discuss yung solution. Medyo mahaba-haba yung solution nito tsaka masyadong matagal yung paggawa ng figure kaya ililipat ko siya dun sa whiteboard na na solution. Okay? Pakihintay na lang po yung solution nito, but for the meantime, try to answer this on your own. Question